is about conjugate beam method in case of cantilever beams. So our first question is, a cantilever beam AB of length L carries point load W at its free end B. Find slope and B and deflection and B. So first of all we will draw M diagram in case of this beam, which is equal to M diagram. And now we will draw conjugate beam diagram, and in case of conjugate beam our free end becomes fixed and fixed become free. So here is conjugate beam diagram. And thickness is M by EI. So we will find first of all slope at B for given beam, which is equal to shear force at B for conjugate beam, and we know shear force is equal to algebraic sum of forces. So in this case there is this triangle whose area is equal to 1 by 2 base into altitude into 1 upon EI thickness, which is equal to WL square upon 2 EI. So shear force at B for conjugate beam is equal to WL square upon 2 EI, which is equal to slope at B. So slope at B is find out. Now we will find deflection at B. Deflection at B is equal to bending moment at B for conjugate beam, which is equal to this area WL square upon 2 EI. That is, if we draw free body diagram, this is our WL square upon 2 EI, and we know from this side and from this side L by 3, and this is B equal to distance 2 by 3 of L, which is equal to WL cube upon 3 EI. So this is the first case of conjugate beam. Now we will move on our second case, which has a conjugate beam has a UDL of W per unit run running over a whole length L. Calculate slope and deflection at its free end. So we will draw first of all M diagram, which is equal to WL square upon 2, and shape is like invert parabolic shape. Now we will draw M by EI diagram or conjugate beam diagram. And this whole length is L. So we will find slope. If we name it as A and B, and in case of conjugate beam, this end becomes fixed end. So slope at B for given beam is equal to shear force at B for conjugate beam, which is equal to area of invert parabola. We know area of invert parabola 1 by 3 into base into altitude into its thickness, which is equal to 1 by 3, base is L, altitude WL square upon 2, and thickness is 1 upon EI, which is equal to WL cube on 6 EI. Now we will find out deflection at B for given beam. That is equal to bending moment at B for conjugate beam. Which is equal to WL cube upon 6 EI into its perspective distance 3 by 4 L. As we know, in case of L invert parabola, if it is invert parabola and it is free body diagram, WL cube upon 6 EI, when we convert it into free point load, so this distance is 3 by 4 L and this distance is L by 4. So from where 3 by 4 L come. which is equal to WL4 upon 8EI. Now we will move on to our next case, that is if there is a movement clock and there is a couple m naught at free end, then we have to calculate slope and deflection at free end. So first of all we will make m diagram, which is equal to m naught, and this length is L. Now we will make conjugate beam diagram or m by EI diagram, which is equal to thickness 1 by EI, length is L, and this ordinate is m naught m naught. Now first of all slope at B is equal to shear force at B for conjugate beam, which is equal to this area of rectangle m naught into L up into thickness. Second, deflection at B, bending moment at B for conjugate beam, which is equal to m naught upon L EI, and this will act in L by 2, so L by 2 m naught upon 2 EI. So this is the concept of conjugate beam in case of cantilever.